53, my instructions are to use the limit definition of the derivative to find the partial derivatives with respect to x and with respect to y of this function. Okay, the partial derivative with respect to x of f evaluated at xy is defined to be the limit as h goes to 0 of f evaluated at x plus h y minus f of xy over h. And that is to say, you're only going to let the value of x vary. Okay, that means you go through here the expression for f of x and replace all the x's with x plus h's. 1 minus x plus h instead of x. Notice I put it in parentheses so the minus sign will be distributed. Plus y, I do not replace y with y plus h. Y stays y. Minus 3x plus h squared, notice the parentheses, times y. I say notice the parentheses because this is the common mistakes I see students make, is failing to put in parentheses. Okay, and then I subtract from that f of xy, which is simply this expression with x replaced by x. That is to say, everything stays the same. 1 minus x plus y minus 3x squared y over h. Okay, so that was a mistake because I had limb blindness. I needed to write in the limit as h goes to 0. Now, it's not a mistake. Always carry that limit. It is important. If you don't have it, then you're probably lying because in the end, this limit will not depend on h, right? H is a dummy variable of the limit. And so if you erase the limit, then all of a sudden h just continues being a dummy variable and is a free variable. So I was wrong when I had a lack of limit there. At any rate, as I've told you before, it's not a hallmark of good mathematical writing to slash things. Okay, so I know you're probably looking at the saying 1 minus 1 and negative x minus negative x. All those just get rid of each other. Do not slash, okay? So slashing just looks bad, and it is only comprehensible to you in the moment. If you wish someone to read this work later, then what you really need to do is find another way. Here's what I do instead of slashing these days. I look at every term. I kind of embolden the underlining, okay? So I see I've looked at 1, and that 1 over here also. Okay, that just gives me a little reminder that I've looked in these two places. Those two things get rid of each other. All right, 1 minus 1 is 0. Similarly, x and x get rid of each other. And the h is going to stay right there. So minus h. H does not get canceled with anybody. Now I'm going to underline it to remind myself that I have looked at it. Okay, that way I won't look at it again. Negative h stays in the numerator. Okay, plus y. The y here and the y here will get rid of each other. That's fine. I don't need to write any y's here then. And then what do we have? A minus 3x squared. Okay, so I need to think about whether or not this and this get rid of each other. I'm going to be careful. I'm going to write minus 3, and then instead of x plus h squared, I'm going to write x squared plus 2hx plus h squared times y. Okay, so now I've written all of that out. And I should also subtract that, but it had a negative sign, so that's going to be a plus 3x squared y. All right, now looking up here, I have underlined everything in reinforcing my line for division, and I have not crossed things out. I find this more helpful, by the way, than crossing out because it serves as a reminder of what I have and what I have not looked at so far, which is more than crossing out does. Still have an h down here. Now, it occurs to me that Negative h will stay there. SH will still be here. The negative 3x squared y, this guy right here, and that right there, those are going to cancel each other now. Right? Negative sign on this one, negative 3x squared y, and positive sign on this one. So that's all gone. Minus 3 times 2hx. Okay, so that is 6hxy. Putting that y in there. And then I also have an h squared term, which is negative 3h squared y. And that is the h squared term. Now, I've already dealt with this, so I don't accidentally write it again. Now, it occurs to me that I have an h in every single factor up here, and in this factor I have 2. So I could write this as the limit as h goes to 0, negative 1 for this term, minus 6xy. I've canceled the h. And then minus 3h times y. So I've looked at that term, got that, and I've looked at that term and got that. Works for me. And then these two terms right here are independent of h, so they don't go anywhere, and this one just simply has an h to the first power. And I could reference some of the limit rules to say that the limit as h goes to 0 of h times a constant is 0, but I do not need to. I think everybody knows what's going on there. Negative 1 minus 6xy. And let's take a look at what we're calculating. The derivative of this with respect to x. Right, the derivative of 1 is 0. The derivative of negative x is negative 1. That's where we're getting this. The derivative of y is 0, so we don't get a term for that. And the derivative of negative 3x squared times a constant y is 6x to the first power, and that constant y is still sitting there. Everything worked out just the way we thought it would. In order to finish off this problem, I need also to look at the derivative with respect to y of f, that function evaluated at xy. That is defined to be the limit as h goes to 0 of f of x comma y plus h minus f of xy over h. And so that this video is not of ridiculous length, I will leave the rest to you.